In this video, we will introduce the RMI architecture within the Java programming language. RMI's purpose is to make the objects in separate JVMs look alike and act like local objects. The JVM that calls a remote object is usually referred to as a client, and the JVM that contains a remote object is the server. One of the most important aspects of the RMI design is that its intended transparency. Applications do not know whether an object is remote or local. A method invocation on the remote object has the same syntax as a method invocation on a local object, though under the hood there's a lot more going on. In RMI, the term server does not refer to a physical server or application, but to a single remote object having methods that can be remotely invoked. Similarly, the term client does not refer to a client, but actually refers to the object invoking a remote method on a remote object. The same object can be both a client and a server. Although obtaining a reference is a remote object is somewhat different from doing so for local objects. Once we have the reference, we use the remote object as if it were local. The RMI infrastructure will automatically intercept the method, find the remote object, and process the request remotely. This location transparency even includes garbage collection. A remote object is always accessed via its remote interface. In other words, the client invokes methods on the object only after casting the reference to the remote interface. The RMI implementation is essentially built from three abstraction layers: the stub or skeleton layer, the remote reference layer, and the transport layer. In this diagram, for illustration purposes, we also show the application layer, or our application code. As we can see here lies our application. Within our application is going to be the client, or the server. Following that is going to be the stub and skeleton layer. This layer is responsible for managing the remote object interface between the client and the server. The stub and skeleton layer of RMI lie just beneath the view of the other Java developer. In this layer, RMI uses the proxy design pattern. In the proxy design pattern, an object in one context is represented by another, or a proxy, in a separate context. The proxy knows how to forward method calls between the participating objects. The following layer is the remote or reference layer. This remote reference layer defines and supports the invocation semantics of the RMI connection. This layer also maintains the session during the method call. Following that, we also have the transport layer. The transport layer makes the stream-based network connection over TCP/IP between the JVMs and is responsible for setting and managing those connections. Even if two JVMs are running on the same physical computer, they connect through their host computers' TCP/IP network protocol stack. RMI uses a protocol called JRMP, the Java Remote Method Protocol, on top of TCP/IP. As we can see here, the client goes through the stubs and goes through each of the layers to be able to access the server. This concludes our discussion of the RMI architecture in Java.